Welcome to a tutorial on solving word problems using equations presented by the Regent University Math Tutoring Lab. There are 4 steps to solving word problems using equations. First, we need to dissect the word problem to find the information we need for our equation. Second, we need to set up our equation using the information we gleaned from our word problem. Third, we need to solve the equation for what the problem asked us to find. Finally, we need to put our answer to the equation in the context of the problem. The first step is to dissect the word problem to find our important information. First, we need to read the problem in its entirety to understand the context of the problem. Second, we want to skim through the problem again and write down all of the numbers we are given along with their units. Finally, we need to read the problem one more time and write down what the problem is asking us to find. Once we have all of our information, we need to organize it in a way that makes it easy for us to see what we are working with. Now that we have our information, we need to set up an equation. To start, we need to divide the information we just wrote down into 2 categories based on which side of the equation each piece will go on. Each side of the equation needs to represent a quantity with the same value as the other side. Once we decide what side each piece of information goes on, we need to decide what our starting variable will be. If we are only solving for one thing, we will only have one variable. Generally, we use x to represent this variable. If we are solving for multiple related things, we would choose x to be the variable that makes our related variable simpler, since they will be written in terms of x. Once we write down our starting variable, we need to write down any other unknowns that we have represented in terms of that variable. Usually, this means that our starting variable is operated on by a constant. If we need to add or subtract, we need to put parentheses around our variable and the operation. Sometimes word problems will need equations with variables of powers bigger than 1. However, the process for setting up the equation is the same for any word problem. Quadratic equations are generally needed if 2 related unknown quantities need to be multiplied together to equal the other side of the equation. Once we have all of the pieces of our equation, we need to represent them mathematically with an equal sign between the 2 sides of our equation. We need to include all correct signs, grouping symbols, and operations. Once we have arranged all of our information, we should check to make sure it lines up with what's in the word problem and what we wrote down. The next step to answering our word problem is to solve the equation. This means we need to isolate our variable on one side of the equation and have a single number on the other side of the equation. We use the order of operations in what will seem to be reverse to manipulate both sides of the equation at the same time. To do this, we need to perform the same operation with the same values on both sides of the equation to keep it balanced. First, we need to deal with terms that do not include a variable. Then we will isolate our variable. Once we isolate our variable, we have solved for x, but we aren't quite done. We still need to find what the variables that were written in terms of x are as well. We do this by plugging the value of x into the other variable expressions and performing the indicated operations until we have a single number. The final step to solving our word problem is to take the numbers we just found and put them in the context of the problem. Each problem will ask for answers in different units. Sometimes these units are asked for at the end, but other times we will need to figure out what our units are based on the information and our equation. It is important to check to make sure the units we have from our equation line up with what we were asked to find. We can do this by plugging the units we used into the equation and solving. This becomes particularly important when dealing with geometric formulas or scientific problems. Once we check our units, double-check to make sure we answered all of the questions we were asked. Now let's solve a word problem using the process we just learned. We are given the following problem. Regent University recently conducted a giveaway for its student body. They sold raffle tickets for 3 prizes, a grand prize and 2 runner-up prizes that were each worth half the value of the grand prize. The person who sold the raffle tickets was paid $50 for their time. If 250 raffle tickets were sold at $5 per ticket, and the university recouped $2 per raffle ticket, what was each prize worth? Now that we have read our problem, we need to write down all of our given information. For this problem, we want to organize our information into two columns. One represents the university's expenses, and the other will represent the university's income from the raffle. Under the expenses column, we need to put the price of each prize and the cost of selling tickets. We don't know what the prices for each prize are yet, so we will use question marks for them here. We know that it costs the university $50 to sell the tickets. The university's income for the raffle is represented by the 250 tickets sold, along with the $5 they were sold for, and the $2 that the university made in net profit. To set up our equation correctly, we need to ask the following questions. What are we solving for? The last sentence of the word problem tells us that we are looking for the value of the 3 raffle prizes purchased by the university. What are our constants? The information from the problem tells us the cost of selling tickets is $50. There were 250 tickets sold. Each ticket cost $5, and the university made $2 per ticket. What is the relationship between our variables? We know we have more than one based on the question marks we wrote down earlier. We have 3 prizes, 2 of which are worth half the value of the third. Now we're ready to create our equation. The first step is to determine what each side of our equation will represent. Using the same organization as earlier, we can equate each individual cost on the left side of the equation to total cost on the right side. The individual costs should add to the total cost and give us a balanced equation, even if we aren't sure what some of these costs are yet. Next, we determine our starting variable. Let's use x to represent a runner-up prize. This means that the other runner-up prize will also be represented with an x, and the grand prize will be represented by a 2x because it is twice the value. We can go ahead and add these variables together on the left side of the equation, since each prize is an individual cost. The $50 paid also gets added to the left side of the equation as an individual cost. We know the total cost to the university can be represented by the difference between the price of each ticket and the profit from each ticket multiplied by the number of tickets sold. Let's go ahead and put 250 times the quantity 5 minus 2 on the right side of our equation. Now that we have our equation, we can go ahead and solve for x. We start with 2x plus x plus x plus 50 equals 250 times the quantity 5 minus 2. First, we want to simplify each side of the equation. We can combine 2x plus x plus x to 4x because they are like terms on our left side. We can also work within parentheses on the right side of our equation to get a 3 from subtracting 2 from 5. This gives us 4x plus 50 equals 250 times 3. Next, we multiply 250 times 3 to get 750. Now that we have simplified our equation, we need to isolate our variable on the left side. First, we subtract 50 from each side to move it to the right side of the equation. This produces 4x equals 700. To get x by itself, we need to divide both sides by 4. This gives us x equals 175. Notice that we used the opposite operation when we moved each of our numbers from one side to the other. Now that we know what x equals, we can find 2x by plugging in 175 in for x. This gives us 350. We can assume that our units will be dollars because we were asked to find the price of each prize. But let's check to be sure. If we used D for dollars and T for tickets, we see that we start with dollars on the left and 2 different units on the right. Operating on these units leaves us with just dollars by the time we get to where x is isolated. We can also put our units in the equation and work on them simultaneously with our numbers. Based on what we were asked to find, we know that the grand prize was worth $350 and each runner-up prize was worth $175. Now we have the information we were asked for, we have completed the word problem. Thank you for taking the time to learn about solving word problems with equations and for making the most of your Regent experience.